Hi everyone, David Maley here. Today we're going to show you how to do some quick linear regression. And what we're going to do is we're going to actually do some forecasting. I'm going to show you how to predict with it. We're going to do everything from the beginning to the end. So let's start here. Basically first let's start with loading the libraries. So you can see right here we have ReadXL, Tidyverse, and Zoo. So you'll need all three of these because we're going to use them through this. Let me open this up so you can see what we're doing here a little bit better. And the data set I'm using today is from the University of California, Irvine, and it's from their data science dump, or they have a bunch of data science data sets for you to use, and this is the automotive one. So this is basically an actual test that people would get usually for a data science position. They love to throw this one at you. What can you do with this data set? And it'll be something similar to this. So without further delay, let's get into this. So first we load it in right here into a data frame called test data 3. I've read this and I've already downloaded this, and it's in Excel. I put it in Excel. It comes in a .data format. Just go and put it into Excel. It's very simple to do. Then once we've done that, so we've loaded the libraries, we've loaded the data set. Now what we got to do is we got to get the column info. So let's actually take a look at this data set, test data 3, right? So let's take a look at it. Here it is. You have miles per gallon, cylinders, displacement, horsepower, weight, acceleration, model year, and then you have these columns H1. I went and took this in Excel, and I took these things and split them out. So I have, you know, the car type, and then I split it out so I actually have the manufacturer and the car name out of that. It's very simple to do. I could show you that in other videos if you want, and I have some other videos that actually show you how to do this kind of stuff. But let's get back to this. The main thing here is not Excel. The main thing here is R. So what we're doing here is number 3, get the column info and identify columns that need to be numeric and our characters. When you bring in data from Excel, R will read it as it wants, and sometimes you'll see stuff that isn't in the format you want. So if I hit this, you'll see here a breakout of these. Now I've already changed these into numeric format, but some of these came in as characters. So you can see right here I had to change miles per gallon came in as character, horsepower and origin came in as character. If I want to use those in coefficients to measure them, I need to have them in numeric format. So right here underneath, so first start off with this str function to go and get this, which will tell you exactly what fields you have and what their format is. Then you will use this where you just say as.numeric and test data 3 $ miles per gallon, because that's the field in the data frame, and they'll switch it to as numeric if it's character. You need to do that. Next, what we do is we do number 4. We remove NAs from numeric columns. If we leave those in there, it will not work. So what we do is we hit again the summary thing. So it's kind of like str. So let's do this. And what this does is it tells you in a little bit different format what you have, what the different fields are or columns are, and what's inside them, what their data ranges are. I'm not worried about that right now. What I'm worried about is this piece right here. See this NA's 6? That was the column of horsepower. So horsepower has 6 NAs in it. We need to take care of that. None of the others have NAs in them that I can see, which is good. Oh, no, wait, miles per gallon does right there. See it right here? 8. So we got 8 in there and 6 in here for horsepower. So we have to remove those NAs, because if we don't, when you're on a coefficient, you'll just get NA. It won't give you any meaningful information. So the next thing we do is this line right here. What we do is we replace the value with the aggregate, which is the numeric mean of the column. So what that does, we have to use this right here, the replace function of our data frame, which is test data 3, true, lapply test data 3, comma, na dot aggregate. That will do that into, and I don't put it back into the same data set because I want to use that same data set later. So now I'm going to use it into this test data 4. Okay, so the original data set is this test data 3 as it came in originally right here. Okay, so now that we've done that, if you were to look at this, that removes those NAs from it. So if I look at test data 4, I can either hit it here or I can go over here and click here. Now if you look at that, it won't have that. Or I could even do, let's go back here, back here, back here, back here, back here, and let's do this. Let's do the str function on test data 4. Right? This is the quickest way to do it. So if I do this, actually not str, I'm summary. We want summary. Okay. So summary, let's just, oops, I've got too many lines of code here. There we go. There we go. So now we look at this. Remember horsepower had NAs? They don't now. See it right there? And MPG had NAs? It doesn't now. So neither one of them does now. We're good. So now we can move on to the next one. Let's hit a row there. So next is number 5. We're going to determine the correlations. How meaningful are these things? Are they meaningful or are they non-meaningful or non-significant relationships? So what we want to do is you want to look at it. Closer approach to 1 is a stronger correlation or to -1. So remember that 0 is not a strong correlation at all, close to 0. But if as we go stronger to 1, we have a strong positive correlation, which means as 1 goes up, the other one goes up. So as x goes up, y goes up. Or if we have close to a -1, we have the opposite. We have a negative correlation, which means as 1 goes up 1, the other one goes down 1, or something like that, depending on where it is, closer to 1 or -1. So what we're going to do is we're going to look at, so remember these fields we have miles per gallon, cylinders, displacement, horsepower, weight, acceleration, model year, H1, which is meaningless. That's where we split off the name of it and stuff. Origin, and J1 and K1. What we really want to stick with is origin, model year, and any of these guys, cylinders, miles per gallon. And it's pretty simple to see this. So what we're going to do here is we're going to do a correlation. So the first one I want to do here is miles per gallon in cylinders, right? Think about it. If cylinders numbers goes up, right, you go from a 4-cylinder to a 6-cylinder, 6-cylinder to 8-cylinder, what's going to happen? Your miles per gallon should go down. Let's see if that works here. Okay, so let's run this, and we have an NA. Let's see here. Oh, you know what? You know why? This is why I wanted to put this here on purpose. I left this here on purpose. See how it's got test data 3? Well, think about it. That was the original data set, which has NAs in it. That's why I told you you don't want to have those NAs. So now look, the same exact code right here with what? Test data 4 in it. See, it's the same exact thing, but we're using test data 4. Now let's use that. See, now we have a correlation. So if you leave NAs in it, correlations won't work. They'll give you crap. They'll give you NAs. You don't want that. So we have that. It's got a what? It's a negative 0.76. So it's closer to a -1. So it's a very strong correlation, a negative correlation at that. So it's exactly what we thought. As cylinders goes up, miles per gallon goes down. Okay. So next, we also want to do it for miles per gallon and weight. What would that do? If the weight of a vehicle goes up, right? Think about it. Miles per gallon should go down. Let's see if that works. Boom. We got an even stronger correlation. So as weight goes up, miles per gallon goes down very fast. Okay. Now we also want to look at, so we're still looking at correlations. What if we do model year and miles per gallon? So think about that. If the model year, so as we go newer, right, in cars, the miles per gallon should go up. So as the model year goes up, we should get more efficient with miles per gallon, right? Think about it. You should, right? So let's hit this, and boom, there we go. Yep, we've got a positive correlation. Not quite as strong as the other two, but it's still, it's over 50% of the way there, so it's a strong correlation. And so what that means is the model year increases, we have increasing efficiency and better miles per gallon. Okay, what if we do origin? The origin of where this car was manufactured, and miles per gallon. So let's see, does that have an effect? It has an equally strong effect, just about the same. So maybe they build vehicles that are more efficient in America and less efficient in South America. Maybe they have less stringent fuel tests and inspections every year down there, or if they even have them. Mexico has a very loose inspection policy compared to many states in America. So that's this is right on line with what we know. So next, we've already looked at that, right? We've looked at the origin, and what about model year instead? So if we take origin instead of miles per gallon, what about origin and model year? What does that do? we have a problem. You know why? Think about it. I think in this case the model year is misspelled, so that would be why. Let's do that. That was from an earlier run, so let's do that. There we go. And it's a very small correlation, so you got to make sure in R it's very particular. If you misspell things, or if you've changed the way a field looks, if you edit it in Excel and bring it back in again, and you don't change the spelling, it'll give you an error. That's what we had there. Okay, so it didn't like that because it couldn't see the model year column with the space in it because it no longer has a space, and I fixed that in Excel, and that's what happened there. But regardless, we got a very, very small and insignificant correlation there with model year and origin. Okay, so next, let's go now. I want to show you one line of code here. So if I had all numeric columns, right, I could run just correlation and test data 4 in there, and it would run fine and give me correlations for every single column against each other. But you know what? I don't have that. I have columns that have characters which have the name of the manufacturer, the model type of the car, and it won't do that in this case. That's fine. I just want to give you that in case you have a set that's all numeric. You can do that. Okay, number 6. Let's build the linear regression model and test the fit with summary and ANOVA. Okay, so let's first start. Linear regression is very simple to do. It's this LM function right here. Okay, so what you do is you take LM, you take the two fields, right, that we're going to use. So we've got back here, we decided, what was it? We had, let's see here in our correlations, we had miles per gallon, right, somewhere in here. There we go, miles per gallon. And then we had model year. So we're taking that one, which had a what? It had a positive correlation, I believe. So if we take that one, this is how it works. We just have data equals test data 4. Remember, we're not using test data 3 at this point. And then we've got the miles per gallon and model year and LM. So and that puts that into, I've labeled it linear regression model 1. So let's run that. And then I've got the one below it, so it's just going to run it, and it puts it over here. And then we've got the next one. We're going to run it again for miles per gallon and cylinders, right? So we've got two of them, right? Cylinders, right? Which is what? As cylinders goes up, miles per gallon goes down. So that one, the second one, number 2, is a negative correlation, and number 1 is model year and miles per gallon. So as model year goes up, miles per gallon goes up because efficiency increases over time. People create more efficient cars. There's new inventions that increase gas mileage, who knows, okay? So next, let's go and print these guys. So we've run them both, and here we get this. This gives us the coefficient intercepts and a little bit of information on it, but what I really want to do is show you something here we're going to get to in a second. Okay, that gives me the intercepts if I want that, but I really want these R squared values, right? So next I'm going to run summary of each, right? So the summary function gives me a whole lot more. Look at that. And what I really want to pay attention to in here is the R squared values, these guys right here. Those and the p-value. You want the p-value to be less than 0.05 to be significant. Okay, that's obviously at 2.2 e to the negative 16. It's a very small number, very tiny, and so we're good. Now this has a 0.3183 for the adjusted R squared and 0.32 for the R squared. You can look at all these different intercepts and standard error values, but that's your main things you want to look at there. Now let's look at the other one. So that was the first one, remember, was the positive correlation, right? And the second one is the cylinders, which is a negative correlation. Let's run that one now. Let's see what that does. Okay, the second one actually has a higher R squared value and a higher adjusted and multiple R squared, and they both have very low p-values. So that's great to know there. Now let's go a little further. Let's go into the analysis of the variance. If you've heard of it, it's called ANOVA, and let's run that here. It's just ANOVA and the actual linear regression model, not the test data 3. It's this that we run. We run that, and it gives you this. Now what you want to pay attention to in here mostly is the mean square of the residuals. So the residuals are, see, when you've got a line like this to the right here, and you've got points out here, the space between here and that line is the residual. Okay, so as they go farther out, they count more. As they're farther in, they count less. And that's how this works. So you want the mean square to be low, and in this case, and your p-value is right here. So we've done that for the first one. Let's run the second one, right? And the second one's even lower for that, which is good. So next, we've run the ANOVA. We've done multiple tests here, right? Let's see the data. Obviously, this is it here, but I want to show you how I do it. So we're going to run the positive correlation first, is this right here, which is a ggplot function. Remember, we brought that in with tidyverse in the library. Test data 4 is our library, or our data set now that we're working on. And we're using the first one, model year and miles per gallon. So we switch those. If we don't, we'll have it going this way, and it won't be as good for when you see down below when I put in confidence intervals, okay? So you want to have it model year, comma, miles per gallon. You put geom point, which will put these points in here, and geom smooth, which gives you this line and shows you the growth and smaller areas. So it shows you not only just the direction, but how it's moving, okay? And then we can also do the same thing. So let's run this. Boom. And then let's run the same thing for the other one. So remember, the other one was what? Miles per gallon cylinder. So it's the exact same code except miles per gallon and cylinders. So let's run that. And that's entirely different. Remember, one was a positive correlation, was going this way. The other one is a negative correlation going this way. So that's the difference between two. Cylinders, miles per gallon. And the other one was the, there we go, miles per gallon and model year. Okay, so next, let's get the predicted values. So there's a reason why we built all this, right? We want to see, we've got all this information going to this, but what happens going beyond this? What if we had 2010 model year way out there? Would the miles per gallon go up? Yes. And so we want to know, you know, what are the predicted values? So in this, let's go right here, this section right here, I want to show you. So what we're going to do first is we use the predict function here on our new linear model 1. I'm using the first one, right? The positive correlation one. Interval equals prediction, so we want to predict it, right? We use this whole line right here, and then we stick it in this new thing called pred linear reg model 1. Okay, that's how our predictions are. So let's do that. And then we go into the next part, which is what we want to take that and we want to append those values back to the original data set. So look, up here where we've been using test data 4, here we're using, we're going to use test data 3. We're going to put it back to the original data set, which has the NAs and all the original values in it. We're taking this right here that we just created, putting it right here, that's our predictions, and we're going to put it to this with a cbind function. It's going to add that right back to it. So if we take that, put that right there, we do that, and then we have it in test data 5. If we want to look at it, we can go here, and here we go. Watch. Somewhere at the very end here, we will see our new predictions of fit, lower, and upper intervals. Okay, that's how that works. So next, let's go back here, and so we've done that. We've gotten our prediction values. We've appended them back to the data set so we can use them for all kinds of other stuff. If we want predictions, giving people graphs and showing them how it's going to be in the future and so on. Next, what we want to do is we want to create a regression line with confidence intervals. So what we're going to do here is we've got model year and miles per gallon, right? We're going to put this ggplot like this. So it's similar to what you just saw up there. But instead we got stat smooth, method equals LM instead of geom smooth, and geom point's the same, and then we got ggplot test data 5, right? Because that's what we just did right here. See this? Where we did this with the appended. So we didn't append, even though we appended it to the original data set, we didn't overwrite the original data set because we don't want to do that. We don't want to have to, in case we mess something up, we don't want to have to bring it back in and go through all that. So I always leave the data set the same, and we put it to a new one, test data 5. Okay, so that's what we're using now. And so what we're going to do is we're going to run this, okay, of model year and miles per gallon as the aesthetics into plot 1. So let's do that. And that's not going to graph anything, it's fine. Then what we got to do is we got to do this guy. We're going to add the prediction intervals, okay? So you've seen this, you know what that looks like. But now we're going to add lower, which is right here, color black, line type dashed. We're going to add upper, which is right here. Y is the upper here. And color is black and line type dashed. So what this is going to do is it's going to take what we did here in plot 1 and it's going to do that plus it's going to add there. So now you have confidence intervals on that show you exactly pretty much most of the data fits in there. Look at that. All of the lower bounds are inside of the confidence intervals. The upper bounds, we got a few that are outside of it that skew it a little bit, but that's pretty good. So it shows you the direction of where things are going for model year and miles per gallon. So as the model year gets newer and newer and newer, the miles per gallon will go up and up and up and up as it should. So that's how you do linear regression. We went through every piece of it here from the very beginning of loading the libraries, getting the data set. I told you where to get it. Here is the URL if you want to use it to go to the University of California, Irvine and do it yourself. We loaded in the data set here. Then we looked at the column info. We identified the columns needed to be numeric because a lot of times R will bring them in and say, oh, that needs to be a character. Oh, that needs to be a factor. They need to be numeric, so I told you how to switch them over. Use the as.numeric function. Then we removed all NAs from the numeric columns because we can't have them there. And I showed you examples of what happens when you have them left in there. That's why I left this one line of code right here, which does what? It shows you the original with the NAs and gives you an NA. Okay, so we want to use test data 4. So remember we used this one to use the columnar means to go and get rid of the NAs. Okay, and then we went through a bunch of correlations in there and I showed you all the code for them so we could play around a little bit and figure out what we wanted to use. I also showed you this extra little bit here in case you have a data set that's different and it has all numeric columns. Go ahead and use it. COR is the function. And just put your test data or your data set's name in there. Next, we built the linear regression model. Its LM is the function. I showed you how to do that. We did that for both a positive and a negative correlation. So we had linear regression model 1 and 2, right? Then we went and built did the summary so you can see the R² values and the P values. We want to make sure they're in line. Next, we did the ANOVAs, right? We wanted to go and look at the residuals. I explained what the residuals were, how the farthest away ones. That shows you they are counted more than the closer ones, and the residual is the distance from the line to the point outside of the line or that area. Next, we plotted these so we could see them. Okay, and I showed you that with ggplot, which is brought in from tidyverse. Okay, you could bring in ggplot itself, but I just brought in the tidyverse, which brings in ggplot and a bunch of other stuff. Next, we got the predicted values and appended it back to the original data set with cbind. Think about it. What good is predicting the values if you can't go put it back to your original data set? You need to show them so you can show people, here's our original data. Now here's the predicted values. And then you can graph them both together. That's what that's for. And it's in a separate column, so it's easy to show it one against the other. Next, I wanted to do show you the regression line, but also with the confidence intervals, which we have right here. So you can see exactly what we're talking about, where this is going, and we did it for the miles per gallon and mile year. We could have done it for any of these other ones, but that's the one I wanted to show you there, the positive correlation one. It could have been the negative correlation, would have been turned the other way. That's all. So we showed you everything from A to Z on linear regression there. You now understand what it is, how to do it. Linear regression, if you don't understand it, it's a way of predicting things, looking at current so current values based on previous values or future values based on previous values. And that's what we've done with this in a linear fashion. Okay, thanks for watching. Please subscribe, like, and share, and also leave me some comments. Let me know what you like. Did you like this? Did you not like this? Would you like to see something else? This showed you a little bit of everything. I show you some little extras in here. We put ANOVA in here. We also put some ggplot graphs and confidence intervals and all kinds of stuff. So we went all the way through it. Take this and learn how to do it. This is one of the things, one of the tasks that you will be asked pretty much when you go for a data science interview, this and ARIMA's. Thanks again for watching, and have a great day.